China's latest rocket just missed its landing by 2 kilometers. On December 22nd, the Long March 12A performed a textbook ascent, separated stages cleanly, and started its return to Earth. Then everything fell apart. Despite years analyzing SpaceX's every move, despite copying their designs, China crashed again. What makes SpaceX's landing system impossible to replicate? And with Chinese startups now planning to catch rockets with tower arms just like Starship, could their desperation to close the gap end in catastrophe? The mission started like any other Chinese launch. At 9 p.m. on December 22nd, Long March 12A roared off the pad at Dongfang Commercial Space Innovation Test Zone. The rocket climbed flawlessly, engines burning precisely as planned. Stage separation occurred right on schedule. For those first few minutes, everything looked perfect. But this wasn't just another satellite delivery to orbit. China had bigger ambitions this time. The real test came next. After separation, the booster flipped around and ignited its engines for the return journey. The target? A landing pad 250 kilometers away in Minchin County, Gansu Province. This was China's attempt to prove they could do what SpaceX makes look routine: bring a rocket home intact and fly it again. The cameras captured striking footage during descent. The engine glowed intensely, exactly what you'd expect from a controlled burn. White vapor streamed from the booster, creating dramatic visuals that suggested everything was proceeding normally. But observers noticed something unusual. That same white plume effect appeared on the upper portion of the booster, nowhere near the engines. Was this normal? Or the first signs something had gone wrong? Here's where the story takes a turn. Despite all the preparation, all the years studying SpaceX's techniques, the booster slammed into the ground 2 kilometers from its intended landing zone. 2 kilometers. In rocket landing terms, that's not a close call. It's a complete navigation failure. The guidance systems that should have steered the booster to a pinpoint touchdown simply stopped working when it mattered most. Now, the Shanghai Academy of Spaceflight Technology issued a carefully worded statement. They acknowledged the landing failed, yes, but emphasized the valuable data collected. That's engineering speak for, we learned what not to do next time, and they're right to frame it that way. The upcoming technical evaluation will scrutinize every millisecond of the flight. Was it a communication failure during re-entry? Did the extreme heat damage telemetry systems, leaving the booster unable to receive course corrections? Or did the engines themselves fail after being subjected to thermal stress, maybe a fuel leak or combustion instability during the landing burn? But here's what nobody's saying publicly. This isn't an isolated incident. In early December, Landspace's Zhuke-3 rocket had almost the identical outcome: perfect ascent, failed landing. Blue Origin's New Glenn just joined the club too. Even with completely different designs from different countries, the pattern repeats. Launch, easy. Orbit, done. Landing. That's where dreams crash into reality, and this reveals something critical about what SpaceX has actually achieved. We've watched Falcon 9 land so many times that it seems routine now, almost boring. But that perception masks the extraordinary difficulty of what's happening. SpaceX didn't figure this out in a few attempts. They spent over a decade, endured spectacular failures, exploded boosters on drone ships, crashed into the ocean, and systematically eliminated every possible failure mode through relentless testing. The company has now landed Falcon 9 boosters more than 500 times. Booster B-1067 alone has flown 33 missions, 33 times launched, 33 times landed safely. China's approach is fundamentally different, and that difference might explain why they keep failing. Instead of developing their own unique recovery architecture through gradual iteration, Chinese programs are attempting to skip straight to copying the final product. Some programs even mix elements from different SpaceX vehicles into single designs, as if you could Frankenstein together a reusable rocket from parts of Falcon 9 and Starship. It's like trying to recreate a master chef's signature dish by copying the final plating without understanding the techniques, timing, and years of refinement that went into the recipe. And now it gets even more audacious. Several Chinese companies aren't just copying the landing legs approach, they're going straight for Starship's most radical innovation, catching the rocket with tower-mounted mechanical arms. Cosmolab, also known as Beijing Dahang, released images months ago showing their Leap rocket concept with catch arms that look remarkably similar to SpaceX's Mechazilla system. More recently, Astron Stone, officially Yushi Space Aerospace Technology, announced their own catching arm project. Unlike others who stay quiet about their design influences, Astron Stone openly stated they're fully aligning with Musk's SpaceX approach. Think about what they're attempting. SpaceX took years to develop, test, and validate this system. They built it for Starship, a vehicle they've been flying iteratively, gathering data on every catch attempt. When Starship's booster successfully caught on Flight 5, it represented thousands of hours of simulation, sensor development, and software refinement. The precision required is staggering. Grab a 20-story building falling from the sky at exactly the right moment with zero margin for error. If it works, it's revolutionary. If it fails catastrophically, you've just destroyed your entire launch tower, potentially setting your program back years and wasting billions. Can China really close this gap? The evidence suggests otherwise. SpaceX launched approximately 165 times this year alone. Falcon 9 has now flown over 580 missions total, and that cadence continues accelerating, not slowing down. Reusability isn't just a technical achievement for SpaceX, it's an operational system running at industrial scale. Meanwhile, Starship development continues advancing. Next year, SpaceX plans two-stage launches targeting full system reusability, something no orbital rocket has ever achieved. Even if early attempts face setbacks, SpaceX's testing pace means rapid iteration and improvement. And while competitors struggle with basic booster recovery, SpaceX is expanding infrastructure. Construction at Starbase in Texas continues at breakneck speed. New facilities in Florida are coming online. Once Starship reaches full operational status, that technological lead might become insurmountable. But China isn't standing still in other areas. Beyond the landing failures, they've revealed significant progress on orbital logistics. New images show early hardware for Qinghao, meaning light ship, a next-generation cargo vehicle for the Tiangong space station. Developed by the Innovation Academy for Microsatellites, Qinghao is designed to be smaller, lighter, and more cost-effective than the existing Tianzhou spacecraft. The revealed hardware looks more like a cargo module than a traditional spacecraft, similar in concept to Sierra Space's Shooting Star. The design places thrusters at the rear, with a large circular opening at the front for docking ports. Reported specifications indicate a vehicle roughly 3.3 meters in diameter, launch mass around 5,000 kilograms, and cargo capacity up to 1,800 kilograms. It includes both pressurized volume for crew supplies and unpressurized sections for external payloads and experiments. Qinghao has reportedly cleared design review, entered production, and awaits systems integration. It's scheduled to fly on CAS Space's Kinetica 2 rocket, with launch timing driven by Tiangong's operational requirements. Meanwhile, Russia is pursuing perhaps the most ambitious and speculative concept yet. Energia has secured a patent for a rotating space station designed to generate artificial gravity through centrifugal force. The design targets approximately 0.5 g through a rotating structure about 40 meters in diameter, spinning at roughly 5 revolutions per minute. Habitat modules would mount radially, using the rotation to simulate gravity. The patent acknowledges massive challenges, particularly docking and resupply operations with a spinning station. Russia hasn't released detailed roadmaps or funding plans. Construction would require multiple launches and likely couldn't begin until after ISS retirement. Given Russia's current economic constraints and industrial limitations, the project's feasibility remains highly questionable. Yet the concept reflects a persistent dream. Rotating habitats have appeared in studies for decades, from NASA concepts to modern commercial proposals. The motivation is clear. Artificial gravity could mitigate serious health effects from long-term microgravity exposure. Whether Russia can realistically pursue this project is another question entirely. So what does all this tell us? SpaceX's landing system isn't just hardware that can be copied. It's the product of organizational culture, software maturity, testing discipline, and iterative refinement that took over a decade to develop. China can build similar-looking rockets and landing pads, but replicating the ecosystem that makes reliable landings possible? That's the challenge no competitor has solved. Here's what China's 2-kilometer miss really proves. SpaceX's landing system can't be copied because it's not just hardware. It's a decade of failures, thousands of test flights, and institutional knowledge you can't steal from blueprints. Chinese companies see the mechanical arms catching Starship and think they can build the same thing. But they're missing what makes it work. The software, the operational discipline, the culture that turns explosions into learning opportunities. While China struggles to land their first booster, SpaceX has already moved on. They've landed over 500 times. They're catching starships with tower arms. By the time competitors master what SpaceX did in 2015, SpaceX will be launching Mars missions. That's not competition. That's being lapped in a race you didn't know had already finished. The gap isn't closing, it's widening. If this breakdown gave you new insight into why copying SpaceX is impossible, smash that like button right now. Drop a comment below. Can China ever catch up, or is SpaceX's lead permanent? Subscribe to New Space Review and hit the notification bell so you never miss our analysis of what's really happening in the space race. Share this with anyone who thinks rocket landings are easy to replicate. Thanks for watching, and we'll see you in the next one.